So in this section, what we're going to do is we're going to get into trigonometry. Well, not this section, excuse me, this chapter. We're going to talk about trigonometry. And now in this section, what we're going to do is first look at what an angle is. And then we're going to see different units of measurement for an angle. We're going to focus on radians. While degrees is something that people use also, radians is actually what most mathematicians use a lot more, especially when you get into calculus and beyond. So we'll see what radians are as well. Okay, so where does an angle come from? Well, first we talk about rays. A ray you could think of as half of a line, although really that's not formal, that's not precise, because a line is infinite in measure. But for now, it's really okay. Formally, if you take a line, let's say we have this line, like so, although it's not straight, but I guess that's okay. Take any point on the line that you want, and then what you're going to do is keep everything on one side of that point that's on the line. So everything over here, I'm going to disregard. And now we have a ray. This point here is what we call a vertex, as in the notes here. We have what's called a vertex. But from a ray, actually two rays I should say, we can actually form an angle. The idea is this. If we have, as the notes say here, two rays having a common vertex as here, we take one ray, we call it the initial side, and we rotate it about the vertex to the other ray called the terminal side. So visually, we're going to take this ray down here at the bottom. I'm going to rotate it up here like so. Doing so, I'm forming an angle. So an angle basically comes about when we rotate about a point called a vertex. Basically, with an angle, you're not only indicating direction, as we'll see, but also how much of a rotation we are doing. So this is actually what we call an angle. So this here, again, the starting ray, so to say, is what we call the initial side. And the ray we end at is what we call the terminal side. That's what an angle is. Now, an angle not only does, as I just said, measure how much of a rotation, but it also measures direction. How do we know? What do I mean by that? Well, because by definition, an angle that's formed by a counterclockwise rotation, as here, is by definition positive. Whereas if you rotate in the clockwise direction, say, let me see if I can draw it over here. So let's say instead I decided to rotate this way. So the initial side is this side, and the terminal side is now down here. This angle is actually negative because we're rotating clockwise. So you know what? Let me actually write that. So this angle is positive. This angle here is negative. Again, that's because of the direction. Also, we have this notion of an angle being in standard position. Let me draw it down here because I didn't leave enough room above. In standard position, that's just when we take the vertex to lie on the origin, and the initial side coincides with the positive x-axis. So basically, you can have something like this. So here's the x and y axis. This kind of angle is in standard position. Again, because the vertex, let me use a different color, the vertex is the same as the origin, okay? So the vertex is that. And also, again, the initial side coincides with the positive x-axis. So that's what we mean for an angle to be in standard position. And that's going to happen a lot because what we're going to do is define trig functions of arbitrary angles that are in standard position. Okay, now before we get to that, let me say this. As I said, I did mention before, there's really two units for measuring an angle. There's degrees and radians. Now, degrees, we might be more useful. There is a formal definition of it, but let me just say this. If you do a complete rotation, let me see if I could draw this. So here's the initial side of an angle. If I were to do a complete counterclockwise rotation about the vertex, so the terminal and initial side are on top of each other, then by definition, this angle is 360 degrees. So 1 degree would be 1 over 360th of this rotation. Now, is that helpful for us? Well, at the time, no. But really, we can think of degrees that way. So as I just said, 1 degree, again, is 1 over 360th of a complete rotation about the vertex counterclockwise. So a 90-degree angle in particular would be a quarter of that, like so. So this would be a 90-degree angle. Okay? That's 1/4 of a full rotation counterclockwise. 180 degrees, let me see if I could draw it under here. That is where you do half of a full rotation in a counterclockwise direction. So this angle here, I don't know if I can fit it. Let me see if I can fit it here, is 180 degrees. And again, this is counterclockwise. Clockwise, the only difference is that the angle becomes negative. So a negative angle, the only difference is you rotate clockwise. So negative 90 degrees, I didn't write it in the notes, that would be an angle like this, 1/4 of a full rotation. But now we go in the clockwise direction. And negative 180 degrees, let me see if I could fit it here. That would be this way. This is negative 180 degrees. Okay? Now that's degrees. Next, we're going to get into radians.